Hey everybody, Mr. Grove here. We're going to talk a little bit about significant figures today. And so significant figures are a way to tell whether or not a digit is relevant in making scientific measurements. So like whether or not you need to measure out a length at exactly 34.23 centimeters, or if you can just round that approximately to 34 centimeters. There's a series of rules that kind of helps us determine whether or not a digit in a number is significant or not. And then that will help determine when we make calculations whether or not we need to count those digits as significant. So let's go through the rules and we'll kind of do some examples as we go. So rule number one is all non-zeros are significant. So that one's pretty straightforward. So if we have the number 400, the 4 is a non-zero, so it's good, but the zeros are not non-zeros, so they are not. So in this case, the number 400, as written here, would only have one significant figure in it. Our second one is all zeros between non-zeros or significant numbers, if they're between significant numbers, are significant. So here we have the number 1,908. So we have a non-zero, a non-zero, a non-zero. So those are all good, which means this zero sandwiched in between them is also significant. So that means that number would have 4 significant figures in it. Rule number 3 is zeros to the right of a digit but to the left of an understood decimal point are not significant. So that's kind of like what we had in example 1. So here's an understood decimal point. We have zeros, and they're on the right side of this number 2, but they're on the left of that understood decimal point. So those zeros don't count. So they would not be significant, and our number would only have one sig fig in it. Our next rule is all zeros that are to the right of a decimal point, but to the left of a number are not significant. So here we have 0.0034. So obviously the 3 and the 4 count as rule number 1, but these two zeros are not going to count because rule number 4 says that they are on the right side of this decimal point and they are on the left side of this number. So therefore they do not count. And so this would only have 2 significant figures in the number. Number 5 rule is all zeros that are on the right side of a decimal point and the right side of a number are significant. So in this case, this 0 is on the right side. It doesn't have to be directly to the right, but it's on the right side of that decimal point and on the right side of this number. So that 0 counts. Well, that means rule number 2, anything in between the 3, which is significant, and this 0, which is significant, would also count. So this number, 30.0090, would have 6 sig figs in it. So that's rule number 5. And then rule number 6 is a little bit old school, but once in a while we have a scenario where we just want a specific placeholder value to be significant. So in this case, we have 3,000, and so we just put a line over that 0 that we want to count as significant. So in this case, since that's significant and the 3 is significant, then this 0 would be significant based on rule number 2 here, sandwiched in between. However, this 0 would be more like rule number 3, so it's on the right side of a number, but to the left of the understood decimal point. So therefore, it does not count. So our total number of significant figures would be 3 for this number. So let's do one last one as an example. And so in this case, we have 0.002030. So obviously, the non-zeros are good. This 0 sandwiched in between, so it's good. This 0 is on the right side of a number, the 3 and the 2, and also on the right side of a decimal point, so it's good. But these two zeros are on the left of a number, but to the right of a decimal point. So rule number 4 says they are not going to be significant. So our total number of significant digits is going to be 4 for this number. So that's how we determine if numbers have significant figures and how many they do have. And later we'll do some simple division and multiplication and addition and subtraction. But for now, I hope that's helpful.